Hello, I'm Robert Reis at the University of Arkansas for Medical Sciences in Little Rock, Arkansas, and I just wanted to tell you a little bit about some of the exciting research that I'll be presenting at RAADfest. The story starts back in the mid-2000s when my close colleague Srinivas Ayadavara and I were working on research funded by the National Institute on Aging to develop a panel of longevity mutations. So instead of looking at things that change as we age, we were looking at genetic factors that determine how long we're going to live. And we were creating this panel such that the only thing that should differ between the different strains of the nematode C. elegans, a little 1 millimeter long roundworm, is the mutation that extends lifespan, and we found a number that had been reported in the literature, a number of mutations that had been reported to extend lifespan by up to twofold, and it turned out that there was actually one gene and two mutations that affected it that extended lifespan by tenfold. And so the fascinating goal now was to see what it was that made eliminating the last traces of its gene product called PI3K, what made that such a potent extender of lifespan. And we started off doing mechanistic studies, but we also explored drugs that might reproduce the effect of the genetic mutation. It's called pharmacopying, and it would give us a longevity pill, if you will. And we did develop some amazing drugs that were much more effective than anything commercially available in reducing the activity of this enzyme PI3K. The problem was that they were very disappointing in terms of life extension. Instead of anything close to tenfold, they perhaps extended life by at most 20%. So more recently, we've been looking downstream at the proteins that bind to the product of PI3K, which is a little tethering molecule that sits in the membrane and that a variety of signaling enzymes attach to very specifically. So they tether to it, they're held in place, and they require that tethering molecule to function properly in that signaling cascade. And we published recently using proteomics to identify for the first time what many of those molecules were, and now we're looking to find specific inhibitors of those molecules or their tethering to PIP3 so that we can selectively just inhibit the downstream effectors whose inhibition will then extend lifespan and separate that from the negative effects so that we don't get any reduction in the ability of our cells to divide when they need to divide. So we're working on that, and we may eventually have a pill that will reduce the burden of age-associated diseases that poses most of the healthcare costs for our society, and maybe it'll be a birth control pill as well. I look forward to presenting more details of this at RAADfest, and hope to see you there.